Everything you've ever known, every star, every galaxy, every atom, even time itself, can be traced back to one extraordinary beginning. Today, we'll journey 13.8 billion years into the past to discover how our universe began.
Okay, let's dive into this, because figuring out what the Big Bang actually was and why scientists firmly believe it happened is essentially the greatest detective story in all of science. We're looking at how the universe transformed from a state of complete, incomprehensible density into the vast, expanding cosmos we see all around us today. But to really understand this, we first have to unlearn a few things.
Section 1. An explosion of space, correcting the greatest cosmic myth.
People almost always picture the Big Bang as, a giant firecracker going off inside some vast, dark, empty room. But that is actually totally wrong. There was no empty void for it to explode into. The absolute crucial fact here is that the Big Bang was the rapid expansion of space itself. It wasn't an explosion happening in space. It was space stretching outwards from a single point, literally creating the dimensions of the universe as it grew.
At the very beginning, there was simply no empty room. The entire universe, literally everything that would ever exist, was compressed into a profoundly hot, unimaginably dense state. It contained all the fundamental building blocks of reality squeezed together. The conditions were so chaotic, so extreme, that the normal laws of physics as we understand them were pushed to their absolute breaking point. This was the perfect setup for a massive cosmic evolution.
Section 2. The Cosmic Timeline. From building blocks to galaxies. Let's move to and see how this builds. It all kicks off 13.8 billion years ago at that singular starting point. Within mere fractions of a second, the universe experienced that rapid expansion of space itself we just talked about. Space swelled outward at a truly mind-bending rate, and eventually this expansion leads us to the cosmic dawn, which is the era where gravity finally begins to form the very first massive structures. But we have to remember, a few vital steps had to happen first to make that dawn possible.
Science is really all about understanding the why before the how. So why did matter actually form? Well, because of cooling. As the universe rapidly expanded, it cooled down. Think of it kind of like steam cooling to become liquid water. That drop in temperature was an absolutely necessary step for all that chaotic energy to settle. This cooling allowed the fundamental forces of nature to separate and stabilize, until things finally cooled enough for the very first atomic building blocks, mostly hydrogen and helium, to emerge from the cosmic soup.
We've literally just covered the birth of reality. If you're enjoying this journey through the universe, don't forget to like the video and subscribe so you never miss out on our future scientific deep dives.
Section 3. Birth of the stars, lighting up the cosmic dark.
For a long time, those newly formed hydrogen and helium atoms just drifted around in pitch darkness. But gravity? Gravity is relentless. It pulled these giant clouds of gas together, condensing them until the pressure was so intense that they finally ignited into the universe's very first stars. Now, what's really interesting about this slide is the sheer terrifying scale of these things. They weren't anything like our sun. We're talking absolute monsters, between 30 to 300 times more massive than our sun. Because of that immense size, they burned millions of times brighter, living these furious, short lives before going supernova.
And of course, these colossal stars didn't just sit there in isolation. Gravity slowly pulled these massive early stars together. They clumped into massive clusters, and then those clusters merged to forge the sprawling, magnificent cosmic factories that we call galaxies. The grand architecture of the universe was finally taking shape.
Section 4. Echoes of the Big Bang, the ultimate smoking gun.
Now, you might be thinking, all of this sounds incredible, but how do you actually prove an event that took place 13.8 billion years ago? Well, you look for the ultimate smoking gun, the cosmic microwave background. When the early universe finally cooled enough for those first atoms to form, light was suddenly able to travel freely through space. And this brilliantly illustrates how that ancient light has literally been traveling through the expanding cosmos ever since. We can point our instruments at the sky today and observe this lingering echo left over from the Big Bang itself. It's everywhere, filling the entire sky, and it is the absolute bedrock of our understanding of cosmic history.
But here is the most mind-bending part of the whole story. The Big Bang isn't just ancient history. It's an ongoing, constantly unfolding story. That expansion of space that started 13.8 billion years ago, it never stopped. In fact, thanks to a deeply mysterious force we call dark energy, the expansion of the universe is actually accelerating today.
The very fabric of reality is stretching faster and faster as we speak.
Okay, let's do a really quick recap to lock in these massive astrophysical concepts. First, and most importantly, the Big Bang was an expansion of space itself, stretching outward from a profoundly hot, dense state. As that space expanded, it cooled, which allowed the first atomic building blocks to form. Gravity then pulled those building blocks into impossibly bright, colossal first stars, and eventually, galaxies. And we know all of this is true because we can literally still detect the cosmic microwave background, the ancient, lingering light of creation.
Our universe is still expanding, and our journey has only just begun. In the next episode, we'll discover how stars became the cosmic factories that created the very atoms inside your body.